Unit 5.7, static. That's the key word. So we look at static methods. I'll write two of them, print and the main. And also we'll look at a static variable called transactions count. So when a variable is declared as static, then a single copy of that variable is created and shared among all objects at a class level. So everybody, all bank accounts would have access to the transactions count. Static variables are essentially global variables. All instances of the class share the same static variable. Okay, so we'll see those ideas later. A static method, on the other hand, can only access static data. So I'll show you that. I'll show you the error. I'll try to access something that's not a static, and we'll see the mistake. And static methods of another class are the same class. So static tends to access static stuff. But the non-static methods, though, have the flexibility of accessing static stuff and also non-static stuff. And so what we're going to do then is I'm going to show you how the transaction count could be used as a static variable, and I'm going to show you the print as a static method that prints not the customer information, but prints the transactions count. Okay. So what we're going to do here is going to print the transaction count. Why? Because it's static. I'm going to show you the error first, and then we're going to see how it works out. All right, so first, let's go ahead and write the print. It's going to be a static method, so it's going to be public static void print. Okay. So let's see, I'm going to say system dot print ln, and let me show you what I meant by showing you the error. Suppose I wanted to print the account number. You get this little error right here. Nice little red line here. Syntax error. Let's put our mouse on that and see. It says cannot make a static reference to a non-static field. So what does that mean? That's what we were talking about up here. If you want to print something in a static method, this too needs to be static. Otherwise, we cannot print a static, a non-static stuff in a static stuff. So static tends to limit what we could do here. If it were a non-static method like this, yes, it could go ahead and print the account number. But this one cannot. So I'm going to leave that mistake and I'm going to go ahead and fix that. Instead of doing that, I want this to be static. So I'm going to make a variable called transaction count. I'm going to go all the way to the top and I'm going to make that variable. So I'm going to add one more to my list right here. I'm going to keep it private and it's going to be an int and it's going to be static as well. And I'm going to start it off as 0. So when this thing first runs, the static transaction count, the static transaction code is going to be 0. And every time a transaction occurs, we're going to increment it. So let me go ahead and look. Well, if I look down here, I think I'm going to need a getter, right? Because how am I going to get the transaction count if I'm in another class? So I need a getter for that. Do I need a setter? No, because I don't want to change the transaction count. I just want, as a transaction occurs, this goes up by 1. So I'm going to go ahead then and make a getter. Let me make it at the very end of all the getters here. So public, it's an int, and I'm going to get transactions count. And I'm going to return the transactions count. So I could get it. And now I need to update it. Well, it can't be updated in the getter. It can't be updated in the setter. No transaction occurred there. It's only 2 places. No transaction in the toString right here. After you add the balance, the transaction count needs to go up by 1. And after I withdraw something, the transaction needs to go up by 1. So all the instances of bank account have access to this guy and should be able to tell you how many transactions have occurred. Okay, so that's how we're going to do the transactions count. Now I could go ahead and print the transactions count now. See, the error goes away because this is static. And because it's static, it's perfectly fine. It could be printed here or worked on here. That's what this thing was saying, that a static method can only access static data. All right, now we have this main method that we need to go ahead and make. So I'm going to go ahead over here inside this unit. I'm going to make a new class to do that. Okay, I'm not going to make the main method inside here. Let's make a main uppercase M. I'm going to include the main method so I don't have to type it. All right, so now that I have my main method, let me clean this up nicely. And I want to create a bank account. So bank account, let me call this A1 equals to new bank account. I'm creating a default constructor. I'm creating a default constructor object here. So yes, he doesn't have a name, his balance is 0, all the good stuff. But what I want to check out is that very same transaction count. So I'm going to go ahead now and print system print L, and I'm going to print A1 dot get me the transactions count. Well, clearly, since this thing did not create any transaction, I didn't withdraw, I didn't deposit, it should be 0. Well, that makes sense. But what if I say A1, go ahead and deposit $100? What would the transaction count be now? Well, let's print it. I'm going to copy it. I'm going to put it right here. So it should be 0 then 1. That makes sense. Because 0, there was no transactions. A transaction occurred, so it's up 1. What about if I make a new object, right? How about if I make a new object, call it A2, a different default constructor created object here. What if I go ahead now and I print A2? What if I go ahead and print A2? That get me transaction. Let's see what prints. 1, 1. That's right, because A2 shares the same transaction as A1, so he knows it went up. What if I tell A2 to go ahead and deposit something? Let's deposit $400. What happens now if I go ahead and print it again? Let's go with A1. Look at that, 2. Mind you, A2 made the deposit, but A1 knows that yet another transaction occurred. 2 transactions, 1, 2. See that? Shared data, static reference. So the static idea here is we want to make sure we could share that information. That's the static variable. Now let me go back to the bank. I'm going to look at the static method print. Okay, so let me go back to my main now. How about if I want to call that? Can I say A2 dot print? See, get that yellow line. Let's put the cursor on it. It says, hey, you're not calling this right. Call it the static way. Well, the static way is not to use the instance of the class, but to use the class itself. That's the right way. So you remember, a method is an action that an object perform non-static, or the class performs static. Let's make a little note. Static call, non-static call. This one is also a non-static call. So let's see if we print that, what will we get? Voila, 2, right? Because the bank account can tell you how many transactions occurred, or the instance can tell you how many transactions occurred. And of course, if we put another transaction, like to withdraw something, let's go ahead and say A2 dot withdraw. Withdraw $100. What do we got? Beautiful. 2 transactions up to this point, 3 by the time we got here. Working nicely. That is how my static method and static variable operates. Let's recap. If you have a static method, only the class is going to call it. Don't use the instance of the class to call it. If you have a static variable, that static variable, cleared up here as static variable, is accessible by everyone at this class level. So even though you're a different instance, you still have access to that. So there's a shared piece of data. Now, since I made it private, I had to make a getter for it. So I could find out the count, and then I did it two ways. I did it that way, or I did it using the print, where the print is static as a method and can only access static instance variables or static data types. That brings us to the end of 5.7.